Hello friends, our today's question of the day is make two array equal by reversing subarrays. Okay, so what is basically given in this question is we are given two integer arrays of equal length, okay, target and array ARR. In one step you can select any non-empty subarray of array ARR and reverse it. You are allowed to make any number of steps. Okay, so basically we are given two array target and ARR. Okay, so we have to take the part of this ARR, any substrings or subarray of this ARR, and we can reverse it. Okay, you can take a non-empty and reverse it. Okay, you are allowed to make any number of, so if we are taking, like, let's say we have taken this part 1 and 3, so we can reverse it, so it becomes 3 and 1. Okay, so we can do these reversing any number of times, like you are allowed to make any number of steps. Okay, so we have to return true if you can make ARR equals to target. Okay, so we have to return true if by performing this step of taking any sub array from this array and reversing it. So while performing this operation, if we are able to form a target through ARR, then we have to return true, otherwise we have to return false. Okay, so the same is given in this question. If return true if you can make ARR equals to target, or false otherwise. Okay, so let's look at this first example which is given to us. Okay, so we have target and we have ARR. Okay, so now let's say we have to make we have to what operation we can do. We can take a subarray, non-empty subarray of ARR and reverse it. Okay, we can take a subarray and reverse it. Okay, so if we do this, like, okay, we have to make this 1 2 3 4 from 4 3 1 2. So what we can do is we can take this one. Okay, so we can reverse this. So 1 4 2 and this is 3. Okay, then 1 is at the place, then we can take this portion. Okay, and then we can reverse it. So 1 2 4 3. Okay, then we can take this portion and we can again reverse this. 1 2 3 4. Okay, so this is what they are asking from us, like we have to take a non-empty subarray and we have to reverse it, and we have to check whether while performing this operation we can form target from this ARR or not. Okay, so this is the approach to solve this. But one thing we know, that there they have said we are allowed to make any number of steps. So here the concern is not how many steps we take to reach from ARR to target, if we are able to. So there a number of step is not our concern. Okay, number of step is not our concern. Okay, so whether we have to find minimum or is maximum number of step to go from ARR to target. Okay, so that is not our concern. We just have to check whether we can form target from ARR. Okay, so okay, now what simple approach we can use instead of doing or performing these operation. The simple approach we can do, we will discuss two approach. Okay, so first let's say we do go for sorting. Okay, so what we can do is we can short ARR. Okay, and we can short target. Okay, so it is already shorted. So 1 2 3 4. Okay, now this also become 1 2 3 4. Now we can, what we can do, we can loop through these as they are of same equal length. Okay, so we can check the element at each index, okay, whether they are same or not. If they are not same, okay, then we can return false. And if they are and if we reach to the end of the element or our loops terminate, then we can say that yes, both the element, both the target and array are same, so we can return true. Okay, so one approach is this. So this sorting, what it will take, it will take capital O of n log n time. Okay, and log n time it and space complexity will, if we will not use any extra space, so it will take constant space complexity. Okay, so sorting understood. What we can do, we can sort this target array and we can sort this ARR. Okay, so after sorting whatever, so we will check element at each index. If they are same, then and we reach to the end. Okay, so we can say that yes, all the elements are same and we can form a target from ARR. Okay, so in that case we will return true. But at any index, if we are getting a different element, okay, so in that case we can say okay, this is, we cannot go from ARR to target, so in that case we will return false. Okay, so one approach is this, through sorting. So it is, we have discussed that it is taking n log n time complexity and space complexity is constant. Okay, now the second approach, where we can perform this in constant time. Okay, and constant space, let's say constant space. Okay, what we can do. So now let's have some constraints. Okay, so here they have said that target value, like whatever the value will be contained in this array, will be in the range of 0 1 to 1000. Okay, so this we can, and array also range will be 1 to 1000. Okay, so this we can use. So what we can do is we can make an array of length 1001. Okay, 10 and 1, because we are indexing from 0. So 0 to 1000, so it will be 1001 element. So we are making an array of 1001 element. Okay, so what we can do is we can store their frequency. Okay, so like at one index we have stored 1, as it is coming 1 only. Okay, there will be 0 0 indexed. Okay, at 2, then 3, and then 4. So we can have two array. Okay, one will store the target frequency. Okay, so it will be 1 1 1 and 1, and remaining element will be 0. And in the same way we will have ARR frequency, ARR frequency. Okay, so here also what we will do, we will store the frequency of these elements. So 1 2 3 4. Okay, so at each index R1 will be stored. Okay, 1 1 1 and 1. Okay, so what we can do now, we can loop through these array. Okay, and we can check whether the element having the same frequencies or not. If they are having the same frequency, so it will be true. They are having the same frequency, so it will be true. Now let's say if in this case only, if instead of 2 4 1, it is all again 1. Okay, and our target array is this. So what will be the case here? Instead of 3, like 3 frequency will be 0. Okay, 3 frequency will be 0, or 1 frequency will be 2. Okay, so here when we will check, compare the frequency for each element now, so at that place their frequency is different, so we can say that yes, we cannot form target from ARR. Okay, so in this way, while using constant, why we are saying constant space, because we have fixed the array, like it is not we have fixed the size of the array is 100 and 1000, or 1001 length. Okay, it will not change in the runtime, so we can say that it is a constant space. And time complexity is capital of N, because we will loop through these target and array. Okay, according to their size. Okay, so now let's quickly implement this. So let's say int vector vector of int target frequency, let's say TF. Okay, so it is 1001, and let's store, initialize it with 0. Okay, in the same vector of int, let's say ARR frequency, and that to 101, and initialize it with 0. Okay, now for int le int, let's say we can only have one loop. For int I is equals to 0, I is less than target dot size, as it is told that they are having the same size, I plus plus. So what we can do is tf of target of I plus plus. Okay, and then same way ARR of f uh, ARR of I plus plus. Okay, and this is we can have store all the frequency. Now we will loop for int I is equals to 1, then I is less than 1001 I plus plus. Okay, now if tf of I is not equals to ARR f of I, okay, we will return false, and if our loop terminates we will return true. Now let's run this and check. So it is accepted. Now let's submit and check whether it's accept. So it is accepted successfully. Okay, so as we know, the time complexity for this is capital O of n, linear time complexity, and with constant space complexity. Okay, so thank you for watching.